Hello. Testing. Hello. Alright. Hello. Alright, so we're going to learn Rust for computer science. Yeah. Alright, I guess that's enough setting up. Alright. Let me set up the camera. Cause it's much more better. There we go. Alright, so we're going to be covering whatever is inside this book right here on the top. So I guess I would do. And yeah, sorry about my streaming quality. I have like a low-end PC. But yeah, let's go. Alright, so chapter 1, it covers the basics of Rust, the installation. Do I really need to go with this? Because I already have Rust installed. I mean, I kinda know the basics already. But yeah, let's just go with it. I won't be reading it entirely on voice because it's quite noisy right now. I am literally next to the TV. And noise reduction ain't enough. So yeah, bear with me. So it's developed by Mozilla. Alright. Installing Rust, I already have that installed. Let's test the installation, okay. We are supposed to build a Rust up project. So cargo new dash dash bin hello world. Alright. So this is our very first Rust application. The cargo terminal file is for the metadata. Yeah, this is basically our package.json if you're coming from JavaScript like me. Alright, so to run, you need to like cargo, right? Cargo run. Yeah, cargo run. Yeah, let's open documentation side by side. Alright, so it only contains a main function. This is where the execution of program begins. It is a function that takes no arguments, hence the empty parentheses, and returns a unit, also written in empty parentheses. The body of the function between curly brackets contains a call to the println function macro. We can see this we can see this as a macro because it ends with, hold on, zoom. Ends with exclamation mark. As opposed to a function, this macro prints a text between parentheses followed by a new line. We'll see what is a macro in the macro section. We'll now change the previous program to add a variable. Alright, I guess we're supposed to add variables now. And as far as I remember, for Rust, in order for your variable to be added to a string, you have to make it inside a string. Like that. Right? Because compared to compared to JavaScript, where you can just put it here, or like other languages, like it's supposed to be like this, right? Like that. But for us, it seems to be like this. So let's make the variable. Okay, now let's remove hello world, the world, I mean, Zavarudo. Now let's put name here, Rust. See, that just proves that I'm a JavaScript developer. I just keep forgetting putting semicolons. Alright, let's run this. And there it is. Now, if we remove this, will it work? It did not work. So we really need hello. Hello. Sorry about that. So like the very first bloopers of my stream. So as you know, I live in the Philippines, cockroach country. And damn. Okay, I don't know why my mic's like this. Like, it's so loud. But yeah, a cockroach actually just flew to me from the window. I am right beside the window. Funny. Actually, I want to hear how loud my mic is. But yeah, a cockroach actually just flew to me from the window. I am right beside the window. Alright, I guess that's fine. But yes, once again, I'm sorry for the convenience. Alright, the color braces part in the string literal is replaced by the content of the name variable. Here we see the type inference in action. We don't have to specify the type of the name variable in the compiler will infer it for us. We could have also written the type ourselves. From now on, I'll omit the main function, but this code should be written inside a function. In Rust, variables are immutable by default. As such, writing the following will cause a compile time error. Wow, so Rust gives us very helpful error message. Let's try that. Sheesh. First assigned to age. So you cannot assign twice to immutable. Oh, this is actually good. It's so better than JavaScript. JavaScript, even if you do a catch with an error, it won't even give you the error. It will just direct you to node modules. We need to use the mutable. Okay, it worked. No chemical age. 43. Cool. Built-in data types. Let's look at the basic types provided by the language, such as integers, floats, booleans, and characters. The following integer types are available in Rust. Unsigned, signed. The U means unsigned, while the I means signed. And the number following it is the number of bits. For instance, the number of the U8 type can be between 0 and 255, inclusive. And the number of I16 type can be between negative 32,768 and 32,767, inclusive. The size variants are the pointer size integer types. U size and I size are 64-bit on 64-bit CPU. The default integer type is I32, which means that this type will be used by the type inference when it cannot choose a more specific type. F32 and F64. Well, I've had like a fair amount of time during Java, so I pretty much know whatever this is. We'll now look at how to write conditions and loops in Rust. Conditions are useful to execute a block of code when a certain situation happens, and loops allow you to repeat a block of code a number of times until the condition is met. Writing a condition. Similar to other languages, Rust conditions are expressed with the if and else. However, they do not require parentheses. Yeah, I remember this. Like, I was like very bad with Rust, and I tried to convert a Java code to Rust, and I made an if statement, and I found out that adding parentheses is not required. Must be of the bool type. You cannot use a number as you would in other languages. Wait, is that one? Oh yeah, that's another thing. Do not forget the semicolon. Okay, let's try making a if loop. Okay, so let's go copy this. Ah yeah, do not forget you don't need parentheses. If number 1 is greater than number 2, we will now print this. Else, would actually print yeah, I don't know why we need that greater than. And also, why is number 2 not working? Argument never used. Wait, why? Still the same. So we gotta figure that out. Formatting. How am I supposed to format this? Because basing here in the book, it's just like that. Oh, I need 2 of this. Okay. I did not see. I am not wearing my glasses. Now we need to return. Okay, let's see the output. Oh wait, so that was not returning. I thought it was an arrow function. So that was just nothing. I thought that was an operator. Okay, now if there's no else, it did not return anything. It needed that else. Because number 1 is not greater than 2. But if we make this like 10, there we go. Now let's try looping to it. So this is the while loop using the Euclidean algorithm. Alright, so let's make a mutable. We're just going to be 15, 40. Now we need to make a while loop. While b is not equal to 0, we will now let temp equal to b. Okay, so what's temp? Wait, temp is like, okay, so you're storing the b variable now inside temp. So is this like a temporary variable now, which is now storing 40? So let's console.log that because I want to see. Is that how you print it? Or is it print it? Holy shit! That's not what I mean. But it's actually looping. Though on just an accident, but yeah, it is equal to 40. So now we're going to b is equal to a%b. And a will be equal to temp. So like, we stored 40 inside temp now, and then b is now equal to a percentage of b. Alright, I forgot what percent is because I haven't done like a strongly typed language in ages. But yeah, we should now be able to return something. we are going to print ln is going to be a. So a is equal to temp now, which is b, and b is equal to a% of b. So let's see. The greatest common divisor of 15 and 40 is 5. What if it's equal to 0? What would happen? It became 15. This code executes successive divisions and stop doing so. The remainder is 0. So you mean we can like add a while here or an else? But yeah. We had a brief introduction to functions when we saw the main function. Let's see how to create functions with parameters and return a value. Here's how to write a function that returns a maximum of 2 numbers. Okay, let's go make a function then. Like this. Okay, that would change something. But for some reason, it's not working. And yeah, it should be working. Or do I need to put something inside first before it works? Or do I even need to add this? Or are those just like this? Okay. Let's go see. Yeah, we don't have parameters. Okay, so it works now. Yay. So it won't actually work until I put something inside. See. The parameters are between parentheses and must be explicitly typed, since the type inference only infers the types of local variables. This is a good thing since this acts as a documentation. Moreover, this can prevent bugs when we change how we use the parameters or change the value that is returned. The function can be defined after it is used without any issue. The return type is after the arrow function. When we return the empty function or the empty parentheses, we can omit the arrow function and type. It's the value returned from the function. You don't need to use the return. The return keyword is only needed when you want to return early. Okay, let's go run. In order to run this, we need to call this inside main, right? Like, let's go call me Max. Is this not how you call it? Why do we need to like make it an I-32 something like that? Sometimes they have multiple values that only make sense together, such as the two coordinate point. Structures are a way to create two types that contains multiple members. Here is how we would create the aforementioned point structure. So let's make that inside Max. Alright, we have a structure called point. To create a new point and access its members, we use the following syntax. Alright, and then we can now print that out. Though yeah, I'm not even calling Max. How do I call Max? We're supposed to variabilize it? Weird. Like that? I what's an integer 32? Let's go back. Dude, where the hell am I? I'm at 50, right? Alright, so I don't know how to call this function, so let's not make it inside a function. Let's put it here. Okay, we got 24 and 42. So we can now call this anywhere, which is just inside main, because I stored two integers. So maybe if we do store it here, like let's make a string inside. Let's see, A will be like 40, 32. We are yet to call, I mean, we are yet to like make this. And then we're gonna variabilize it, let pog equal to pog. Like that. Okay, I don't know. Let's remove this function. Which if I want to add like A here, which will equal to 50, I have to make it here first. There we have A. So why is A? It's never read. We need to call A. Then there we go. Now we just add A. Run. There we go. Not bad. Derive debug. Okay, let's make like there. Whoa, I hate that so much. Wait, what do they mean automatically generate? Wait, so oh, so if you so Rust auto completes it for you? Like Rust fixes your code. Dog. That's so cool. Right now we're at references. Who keeps messaging me? Alright, the messaging should be gone now. Let's try the following code which should work in other programming languages. Let's make a new FN main. I thought there was an autocomplete. Alright. Not found in the scope. Expected a coma. Alright, back prefixing it 100% like this. Wait, oh, so that's why. Is the reason that I'm having point as an error is because I removed this earlier? Okay, not like that. So why is it giving an error? Yeah, still giving an error. Now we're going to make a function called print point. And it takes two parameters, which is point and point. Inside as value of x and y. Okay, I still don't know why point is. I think we really need that point struck earlier. What? How come? Like earlier. Okay, we still can't get the reference of point. Oh, it's because we removed this. So we're supposed to get the reference now. Yeah, still not. So what is the problem? We no longer have that function because we removed it. Are we supposed to make a function inside main? You can? You can! So that's how you make a function and call it inside. You directly type it there. Now we can what call like this now. And there we go, we got, yeah. And still gives the same output. Cool. Yep. Alright, cool. What is a clone? We need to derive this. Avoid moving our P1 point. So we still have this side point. Now we will call P1.clone instead of reference. Now print point P1 clone. Where are we putting the pointer at? Oh, it's just like that. Okay. Alright. Okay, so let's do that function. Let's replace this. Though we don't need that. Alright. So now we will increment P1 variable needs to be a mute. We also need to take a mutable reference for this variable. Like this. No, like that. Then we can run it. Which did absolutely nothing. Alright, so we're supposed to this Alright, so implement. Square root. Alright, we can't call f64 because again. So f64. Semicolon. Oh, this. Okay. Wow. So I wonder what did that do? I guess we're supposed to print this up. This is just, I pretty much already worked with every single one of this. It's just Who knew that it is actually there is much more to it. Okay, now this is what I'm waiting for. So first, of course, we need an array to and then we need a sum of 0. Now for our for loop, it's like a Python for loop. Alright, increment element and then print the sum. Sum is 15. The most surprising part here is the asterisk in sum plus equal to element. Since we get a reference to the element of the slice, we need to do to access the integers. We use ampersand in front of array to avoid moving it. Indeed, we may still want to use this variable after the loop. Let's write a function that returns the index of an element in a slice, or none if not in the slice. Like that. What's an iter? Sorry, JavaScript developer. Alright, so why slice like this? Cannot find value. Or okay. Okay, why can't we? Okay, there. Now for indexes. Go to a print line. Okay, like this. Okay, I do not know how to put that out. I want to try looping something. Wait, is this how you do that for loop? In Rust? Alright, let's try. Oh, just like this. I just incremented then. Okay, how do you increment it? Okay. Alright. I guess I never really call the argument. Hello, one. That's not what we wanted, right? We wanted to print out like hello only. Oh, so it's like that. So we need to. Okay, I'm having a hard time right now. Ryan, 1 to 100. We want to print out 1 to 100. How did we do it? How do we do it? This is not the 1 to 100 we wanted. It's more like we want a text that would be printed out. There we go, so that's how it is. Alright. That was just a place I like, I love you. And then we can make a meme. There we go. So that's how it works. So we don't really need 2 plus 5 plus plus it actually. It really is just like Python. I think I'm ended right now. It's like 10:30. I'll see you tomorrow.